Okay. Everybody can hear me?
Yes.
Nice. Let's see, do we have homework for today? I know we did tree traversal. The reported depth for the for a tree, right? Okay, so before we do that, let's talk about the midterm. So we will have class on Monday. So this is more a preemptive type thing because the midterm will officially be during class time next Wednesday. Remember, fall break starts for classes that start after 4 p.m. a week from, well, next Wednesday. So our official midterm exam time will be our class time on Wednesday next week. The exam is going to be online. I will guarantee that I am available in real time for questions on Slack during our class time next Wednesday. So if you do want to take the exam during the allotted Wednesday class time to take the exam, I will be available guaranteed live to answer any questions. But the exam is on Blackboard. So, I mean, you can come to the classroom and sit there and take it if you'd like, but you can do it wherever you want. I will, however, put the exam up online sometime Monday morning. So what I need you to do is just make sure you submit it by midnight on Wednesday. So you'll have to take the exam all in a single sitting. I won't put a time limit on it. Exam should be about, it'll be exactly 10 questions. Here, I'll write this stuff down. Let's see. How do I create a slide? Oh, I don't know why I chose to open it. Oh, of course, it's whatever. I was thinking I was on a Windows machine. That's why I had to use iCloud Keynote. Midterm officially during class time on Wednesday, that's the 20th, right? I will be available live on Slack to answer any questions during that time. The exam will be up starting Monday morning. And it's even possible I'll have it up Sunday sometime. I'm just basically guaranteeing I will have the exams up by Monday morning. I'll be writing them over the weekend. You need to complete it in a single thing. Plan on about an hour, but there will not be a time limit. So I'm going to be, I'll design the exam to be an exam that I would give in class during a 50-minute class. So typically I would say that, you know, if you're very prepared, good to go, it would be completely reasonable to finish the exam and make maybe 30 minutes. But no time limit. This isn't a time based thing. I want to see what you understand, that kind of stuff. All right, but make sure you've allotted the time, because once you sit down to take the exam, you got to complete it all in that one sitting. But I don't care when you do it, as long as I have the exam submitted to me by midnight on Wednesday. Exam will have 10 questions, 10 points each. There will be at least one conversion question where I ask you to convert a number from binary to octal or decimal to hexadecimal, something like that. So, you know, that's a skill that all computer scientists should have. We teach it in the 200 class. Every one of you should know how to do it. So that should be a free 10 points. Similarly, a fair game question would be converting sizes. I might ask you 3 gigabytes is how many megabits, something like that. So you should be able to go from that. These are things all computer scientists should know how to do. So there'll be at least one question on the exam, probably exactly one question on the exam, dealing with that. The other 9 questions will range between explanation and programming questions. No multiple choice, no fill in the blank. So it's going to be either prove to me you understand something by explaining it to me, or write some code that does something. Keeping in mind that I would ask questions that are in the wheelhouse of things that could get done within a reasonable amount of time, given it's an exam situation. You cannot use a compiler or anything like that. With that in mind, I will be, not be nitpicky about syntax. You forget a semicolon or something like that, not a big deal. I'm mainly looking, are you showing me reasonable competence in working with these things? In the past, what I've done on the exam for this class is I will say, assume there's the existence of a class called linked list or stack, that kind of stuff, with reasonable functions. So maybe with a linked list, you can assume you have an add front, you have an add end, you have a get it index. For us, the stack, you have a push pop peek, that kind of stuff. So I might say you can assume those already exist. Now do something, create an instance of a stack or write a function that takes a stack as a parameter and do something to it. Something like that. So you should understand what those data structures are, being able to do something to them. Here's another warning. I gave it in class, but remember, these data structures, they were written by a smart person at some point in time. So all those details are already built inside. Chances are, if I'm telling you to write a function that takes a stack as a parameter and do something to it, I'm not asking you to be updating pointers and things like that. I'm asking you to utilize the stack data structure to solve some problem. Okay, kind of like we use stacks to solve towers of Hanoi, that kind of thing. So if you find yourself on the exam, unless the question was super explicit about updating pointers and stuff, if you find yourself feeling like you're setting next pointer to temp's next pointer equal to this guy's next pointer and things like that, you're probably not answering the question right. Okay, because I'm going to make the assumption that you've already written the stack, it's already ready to go, and now you're utilizing that shiny new tool that exists. Okay, so you should definitely understand that a stack is a last in first out queue. A queue is a first in first out. Linked list is much more generic. You can kind of do whatever you want with it, that kind of stuff. So the questions will be either kind of an essay question, short answer, tell me something that and prove to me you understand the concept, or write some code that does something. Usually those will come in the form of write a function that takes something as a parameter, does something, and either returns and probably returns a value or maybe prints a value, something like that. Another kind of question I like to put on exams is like, here's some code, tell me what this does. All right, and when I give you a question like that, I'm not asking you to go line by line and tell me what each individual line does. You can do that if you'd like, but what I'm really asking is, look at what I've shown you here. Tell me what problem this solves. Like this problem reverses a string, or this counts all the prime numbers between 1 and 100, something like that. I'm not asking you to go through and give me a blow by blow per line and then never actually tell me what the code accomplishes. All right. You're not losing points for the blow by blow, but you will lose points if you don't tell me what the code does, ultimately solves. Okay. So before I kind of flip through the slides and give you the highlight reel of, because I haven't written the test yet. So what I'm going to do here is I'm going to go through the slides just as I will over this weekend, and kind of, give you a highlight of things that I feel like are kind of important that you might want to spend a little bit more time on when you're preparing for the exam. All right, so before I do that, are there any questions high level about the midterm and how you're taking it and all that jazz? Is that a no? All right, we'll go with a no. Okay, so let me just flip through our slides, and I will highlight things that I think are extra important that you might want to ensure that you have boned up on for the exam. I will say that this being the third programming class, the exam will be more programming centric as opposed to high level theory centric. Not that the theory doesn't, like, in fact, pretty early on here, a certain concept you should definitely understand is, why arrays, why linked lists. So kind of the difference between a linked list and an array, why each one, what each one's good for, what each one it kind of suffers from. All right, so I might ask you, even just that generic question, how are arrays and linked lists different? When might you use each one? Something like that. There won't be any, like, I would call them kind of tricky questions on the exam dealing with like some really screwy old C syntax for calling malloc and walking an array by doing pointer arithmetic. Those are interesting, cool things, like this thing here. Those are interesting, cool things, but I'm not going to be going out of my way trying to trick you on an exam. I just want to see that you're competent, and if you're using new style stuff, that's perfectly acceptable. In fact, I would say on the exam, don't go too far with this where you're just writing me a term paper, but reasonable pseudocode in the event that you just don't quite remember exactly what the function was is fine. As long as the function exists. Like, don't just invent a function that solves the question that I'm asking. It's like, okay, you want to reverse a string? Yeah, here's the function called reverse string for question number 2 on exam. It's a built-in function, I think. Don't do that, but I'm looking for competence, and the compiler will be happy to scream at you if you say the word print instead of cout or something like that. So I'm not going to be knocking you for points for that kind of stuff. I won't ask questions about specifics like how the old style strings work versus the new style string. That was more of a history thing to kind of throw into your memory banks. This class is about specifically data structure. So the exam will focus on the data structure aspect of the class. Let's see. Maybe the role of header files. That would be a fair game, because now we're talking, getting back into the programming stuff. I would say not a super high priority, but it would be perfectly fair game for me to ask you what problem does having a header file solve, something like that. You won't have anything on the exam dealing with structs. We did talk about them. I would say it might be fair game for me when I give you one of the code examples. I'm not suggesting I will do this, but just to leave it open for me to be allowed to do this. It's possible that when I give you code and say, what does this do? It would be fair game for me to use a struct in there for you to tell me what is this doing. Where a struct is effectively a class that doesn't have functions. So it would just be a variable that allows me to have some a single variable name with some different kinds of values, kind of like a Python dictionary. All right, but I won't ask you any questions on the exam specifically dealing with structs. We were kind of talking about the history of data structures and how we kind of evolved to where we are today, but that's not something that will really make its way on the test or that you'll be required to have to or work with. You'll definitely need to be familiar with pointer syntax. In fact, I'm almost guarantee there will be some question on the exam that will require you to prove to me you understand the difference between the star and the ampersand when working with pointers and memory addresses, that kind of stuff. It probably won't be this crazy deep question, but it'll be something that'll kind of be a almost binary grading. Do you pretty much understand memory, or do you really not understand it at all? There won't be anything on the exam dealing with specific value sizes. We talked about that technically in C and C++. It follows the ASCII character set. So in actuality, chars are 8-bit values, where in Java it follows Unicode. So there's 16-bit values. I would not ask a question like, what's the size of a char in C++? Those are more just determining when you're working with a language, what kinds of values you're dealing with. And that might be an important thing to know when you're in industry and you're working with a specific language, just to kind of know what kind of data types you're working with, but nothing that really is something that I'm going to test on in here. You should know that strings are stored as character arrays. I don't know how that would pop up on the exam, but that's something you should definitely be aware of. That starts getting into the area of contiguous memory, that kind of stuff. Again, the idea of pointers. But notice here, like in the slides, I do talk about things like 16 bits versus 32 bits, kind of the rationale for why do we pass a pointer to something rather than to something itself. Again, I won't get into the weeds on an exam about, how big is a memory address on a 64-bit operating system or something like that, because actually the answer is somewhat vague. With the punchline being like, most modern Linux operating systems are 64 bits, yet the size of a memory address is typically 48 bits because they use a smaller 16-bit memory address for the system protected memory addresses that things running in root mode use. So that question like that wouldn't even be a fair question on any exam. Okay. I would point out something here on this slide, depending on my mood when I'm writing one of those questions dealing with, I said a few minutes ago that structs could be fair game on the exam. It would be possible that I might give you code and ask you, what does this do? And it might require you to know that structs are passed by value, not passed by address. So structs in C++ behave a lot like primitive types behave, where when you pass it to a function, it's passed by value. So changes you make to that struct inside that function are not permanent, unless you choose to pass the address of the struct and your function takes a struct pointer. So just kind of, like I said, I'm going through these slides right now as if I was writing the exam. I could see myself giving you some code that says, what's the output of this thing that will require you to understand the difference of what's something passed by default versus if I specifically pass a pointer to it from the perspective of side effect. So I might display something in main, then pass it to a function that manipulates it, and then display it in main again and ask you what would the output of this program be. And you would have to understand that if something is passed by address and you make a change to it, that change was permanent, versus if something was passed by value and you make a change to it, that was only temporary. There could be a high level question dealing with the difference between linear and nonlinear data structures. I'd have to be pretty desperate for a question if I had just asked something so high level like that. But the idea of like our linked lists, our stacks, our queues, these are linear. All the linked stuff is all in a single line. Whereas now we're starting to work with trees, which are nonlinear. We have multiple branches coming off things. So make sure you understand those two terms and what I mean, even if I just use those terms in a question. Not specifically asking about it, but you should understand what those terms are. Yeah, so this is that linked list versus arrays thing. Strengths and weaknesses of each, definitely know that. You won't have to write code on the exam. I would say it might be fair game for me to have you do a coding problem that has a similar complexity to like add front or add end with linked lists. But I think it's far more likely that the coding questions I ask you will require you to just utilize linked lists or stacks or queues as opposed to write them. But I certainly wouldn't ask a question on the exam that had the complexity of like the added index where we had to kind of do the surgery in the middle. So at the very least, hopefully that kind of gives you a rough idea of the difficulty of the programming questions that I would ask on the exam, since you are in a timed manner. And really what I'm trying to pull out here is, how much you've learned on your own. I know I encourage you to work in groups, and I know some of you do, but some of you don't. But really, this is as much for you as it is for me, just to see where you are from a programming competency perspective now that we're in our third semester of programming. And remember, my policy is if you do better on the final exam than you did on the midterm, I'll replace your midterm exam grade with whatever you get on the final. So nobody's going to do so poorly on the exam that their grade is screwed, because even if you get a 0 on it, you can turn it into 100 at a later date. All right, but kind of keep that in mind. I use my exams legitimately as tools to assess where you are. I'm not looking for reasons to take points away from you. So prove to me you understand the stuff, but that you understand it. So don't work on the exam in teams. This should be an individual project. Well, we're going on the honor system because it's your knowledge. They'll find out when you go and get a job if you don't know what you're doing. But work as an individual so we can kind of see where you currently are in terms of where you should be. All right. Certainly understand conceptually the difference between a linked list and a doubly linked list. That might be more of an explanation type question where, what's the advantage of one over the other, or what's the difference between the two, that kind of thing. Similarly, the idea with a head pointer and a tail pointer, what does that give you the ability to do, or how does that simplify things? Something like that. So understand the difference between those dudes. Let's see. Certainly know the 3 functions that are kind of required for the stack data structure. Officially, only 2 of them are required, push and pop. Peak, I just think is effectively required. But in the abstract data type world, if you look in a book or something, stack dictates that only push and pop have to exist. But you know, if I tell you there exists, assume you have access to a stack data structure that's already been written, and any reasonable functions that would be in that stack, you could assume that push, pop, and peak are there. And you should know what each of those does. I would not ask you on the exam to, like, you know, here's your input queue, show me the steps for the shunting yard algorithm or something like that. You know, that was an algorithm that allowed us to practice with stacks and queues and things like that. But the memorization of the algorithm is not something I'm testing you on in this exam. Okay, and then this is the stuff we're just now getting into. It would be fair game for me to maybe show you a binary tree and ask you to show me the order of visiting the nodes in order, pre-order, post-order. So the things we've done very recently. So prove that you understand that concept. It would also be fair game for an explanation question that talks about the depth of a tree. Just you know, I might show you a tree and say, is this out of balance? Where if one side is more than one level deeper than the other, then it's an out of balance tree. We're probably, I would say there's a very low chance of a question dealing with that because we're just starting to get into that. But I would say, since we've talked about it, it would be fair game. Okay, so here's that in order, pre-order, post-order. This would definitely be fair game on the exam. In fact, I would say historically, I like asking this question. So I would say you should be prepared to have me give you a question like that, show you a tree that looks something like this, and for you to list out what in order, pre-order, and post-order would look like for those three, what the ultimate node visit order would be. No promises, but it feels like I ask that question almost every single time I give this midterm in 300. So we'll call that a fairly high priority. And I think that gets us to about, oh, you should certainly know the binary search tree rules. You know, that idea that everything left of a node is less than or equal to, and everything greater than a node, or to the right of a node is greater than it. I might say, given the sequence of numbers added to a tree in this order, what would that tree look like? The only reason that might be a little bit difficult to ask the question just like that is because answering that on Blackboard is a little inconvenient. If we had a piece of paper test sitting in front of you, you can draw me a nice picture easily, that would be you know, a perfectly reasonable question. But on Blackboard, not that you can't go and, you know, draw it and upload an image or something, but, you know, I don't want us to waste a whole lot of time going through a bunch of hoops to answer the question. So I might come up with an alternate way of making sure you understand the binary search tree rules, but you should certainly understand that, know how binary search trees work. Okay. And I think that gets us basically where we are in the class right now. All right, so that covers the what's going to be on the midterm and the format of the midterm and all that stuff. So before we go back and start looking at the homework assignment, are there any questions about the midterm or anything you want me to review before we go on? Worst that happens is we look at the homework assignment on Monday. So it's, if we don't get to it, it's not the end of the world. So if there is something you want me to review ahead of you studying over the weekend, we should do it now. Going once, going twice. Nothing in chat. Okay. So let's look at our homework assignment then. It's right here, right? Binary search tree, ability to report its depth. Okay, so let's see, we are on our binary search tree, this dude. All right, so we're supposed to be, actually, I'm gonna lift it like that, and use that guy. Okay, so we're supposed to be teaching our binary search tree how to deliver its depth. Okay, and this is a effectively an exercise in pseudo recursion. So if we go into our binary search tree, is this the CPP? This is HPP. So we're going to go ahead and we're going to say void, I'm sorry, int get depth. We're going to teach our binary search tree the ability to report its depth, remembering that the depth of, well, the depth of a binary search tree is the 1 plus the maximum depth of the left or the right subtree. Okay. So now we'll actually implement this guy. We'll write it up here. Steal that. Okay, so we know that the current depth is going to be 1. Because a tree has a depth of at least 1 if anything exists, right? In fact, actually, we could start off at current depth is 0, like this. Then we could ask the question if this root is not equal to null. So if there is a root node, then we can say current depth plus plus. We'll have at least a depth of 1. All right. And at the end, we're always going to return whatever the current depth ends up being, with the possibility of current depth being manipulated inside of this if statement here. So if we have a root node, current depth is going to be at least 1. Then we can ask some additional questions. All right, we want to get our left our left depth and our right depth. So we're going to have an int left depth. We'll start off at 0. Our int right depth will start off at 0. Okay, and now those two values can potentially modify, okay, depending on if you have a left child or a right child. So if this root and let's see, so our actually what we're going to do, I'm not even going to do an we're going to make an assumption that something's going to exist. Let's go ahead and write it. So we're going to pause there for a second. We're going to teach our nodes how to report their individual depths. All right, so we're going to have an int get depth, and this is for an individual node. Then we'll go and implement this guy. All right, so just like we did before, we know this guy exists. So we'll say int current depth is going to be a 0. Okay, now it's potentially going to be more. So we're going to have an int left depth will be 0, and int right depth will be 0. All right. And remember, the depth of a node is going to be its current depth, which actually starts off as a 1. Sorry. Okay. So it's going to be its current depth plus the maximum of the left and the right depth. Okay. Now, a node only has a left depth if it has a left child. So if this left child is not equal to null, you could also just say if this left child, if it's a thing. So if this left child is not equal to null, then we're going to say left depth is equal to this left child get depth. That's that pseudo recursion I talked about. We're inside this particular node's get depth. This is calling our left child's get depth. Same function, different person, different instance calling its function. So if we have a left child, let's go ahead and get our left child's depth. If we have a right child, we'll get our right child's depth. All right, so notice that those guys start off at 0. So even if we didn't get inside of one of these if statements, left or right depth will be a number. It'll be a real number. Okay, so now the depth of this particular node is going to be his current depth plus the maximum of left and right depth, whichever of those two numbers is bigger. Okay, so we'll say if left depth is greater than right depth, then current depth plus equals left depth. Else current depth plus equals right depth. Ultimately return current depth. So from an individual node's perspective, he knows he has a depth of at least 1 because he exists. He may have 2 children. So at this point, all he knows is that if he has no children, he's adding nothing to his depth, but he'll start off counters for those. If he has a left child, he'll ask his left child what his depth is, which is going to go through this identical logic for that left child. We'll get a number. If he has a right child, he'll ask his right child, what's his depth? We'll get a number. We'll ask, is the left depth bigger than the right depth? If it is, we'll add the left depth to our current depth. Otherwise, the right depth was greater than or equal to the left depth. And if it was equal to, it doesn't matter which number you add. So we'll update current depth appropriately based on the maximum of our left or right child's depth. And then ultimately this node will return his current depth from his perspective, right? We're going to be calling this function multiple times from different nodes' perspectives, effectively summing up all the things. All right, so now what we can do, I'll go ahead and save so I don't forget. I'll go up here to our binary search tree. And we actually won't keep track of the current depth here because of the way we wrote this. We'll just say if we have a root node, we'll return this root get depth. Else return 0. So if we have, from a binary search tree's perspective, if we have a root node, the depth of this tree is that root node's depth. Otherwise, it's an empty tree, so its depth is 0. Okay. Let me hit save here. Let's see which version of our tree. We move the 8. I'm just going to go ahead since we already have this tree designed. I think the 8 was the last thing we added. Actually, it won't matter because of where it'll end up. So this tree, this 3, 2, 2, 3, 6, 6, 7, 8 should give us this picture right here, which should have a depth of 1, 2, 3, or 1, 2, 3, 4. 4 is the maximum of those two. So this should give us a depth of 4 if we were to call get depth on that particular tree. Add a variable real quick. Oh, because I don't have my IO stream stuff in here because I was doing all my displaying someplace else before. So I'll just do include IO stream namespace. Forgot my arrow there. This guy right here. And this guy right here. Same error. There we go. There's our 4 for that one. And if we build our tree a little differently, let's see. Well, here, we'll jumble those things up a little bit. Actually, what we do, since we have a few minutes, we'll go ahead and let's grab ourselves some random numbers. I think the function is called rand int, but let's just all right, so rand lives in standard lib, and then you actually use something called time. This is actually an interesting lesson to throw out there, just to add a little extra pizzazz to today's lecture. So I'll go ahead and bring a couple of things in here. So I'll bring in standard library, which has our srand and rand. Now these are very old functions. And so really this lesson is not even a data structures lesson, but it's more of one of those history of programming type things. Random number generators are actually fairly complex critters. And this was even a truth like in Java. You know, when you've done Java with me, we've used the random class and used the next int function to get our next integer. Well, in the early days of Java, if you did that, you would get the same sequence of random numbers every single time you ran the program, because you weren't seeding the random number generator. That's what this srand thing is. It allows you to give some sort of initial starting point so that the values you're going to get are truly pseudo-random relative to the last time you ran the program. So if you don't seed your random number generator, you end up typically getting the same sequence of numbers every single time you run the program. Now that can sometimes be what you desire, depending on what you're doing. But typically when you say, I want random numbers, you truly want random numbers is the idea there. So with that in mind, notice one thing they're doing here is they're calling srand. And I'll explain this here in a second. So early on here in my main, I'm going to make a call to srand. So I'm going to seed the random number generator with the current time in milliseconds is what this will give me. So idea is right now it's going to be a different number than it will be 1 millisecond later, then it will be another millisecond later, and so on and so forth. So presumably we should give our starting point for our random number generator a little bit different starting point every time we run this program, where we shouldn't get the same sequence of random numbers every single time. Okay, so then we can use rand to give ourselves a number between, in this case, it's going to be 0 and the size of random number, or size of integer, I believe is what it'll be. We could test that real quick. Let's do a little for loop. For int I is equal to 0, I is less than, I'll just do 10, I plus plus, C out rand and L. So let's just print out the result of calling rand 10 times. I believe it's going to be between 0 and size of int, which should be 2.1 billion. It might give me a value between 0 and 1. Then we would have had to multiply it by 100 from this example. Let's see what we get from this dude. Yeah. Those look like numbers between 0 and 2 billion. All right. But let's say we wanted numbers between 1 and 100. So we would mod that by 100, add 1 to that number, and now we have numbers between 1 and, actually, let's just do 1 to 10. Now we have random numbers 1 to 10. Okay, so given this, now that we have random numbers that we can generate, I can go ahead and we'll build our binary search tree, and then we'll just randomly add a bunch of stuff to our binary search tree. And we'll do numbers between 1 and 100. And let's put 100 values in there. All right, so we'll fill up our binary search tree with random numbers between 1 and 100, and we don't know the order they're going in there. So this depth could be very interesting. We presumably, if we run this multiple times, may get several different depths. Oh, I no longer have a variable called depth because I no longer am running it. So here, I'll just call my BST depth. So there's an 18 for the depth of my first tree. Presumably it's going to be a different depth. There's a 14. There's a 13. We run it enough times, we're probably going to, you know, hit the lottery and get something with like a depth of 70 or something, where it just became very lopsided. So on and so forth. Just kind of a interesting exercise. And we know these, this is a good way of testing our binary tree, where we can say BST display in order. So we know it's going to get it's built right because it'll be in order. So there's its depth 12, but you see pretty good distribution of numbers between 1 and 100. So we know our binary search tree is working. Okay, so any questions about the, so that was effectively the homework with a couple of extra things kind of tossed on there for getting the depth. I saved that so you can go back and review it if you'd like. No homework over the weekend other than study for the exam. We will have class on Monday where we'll tie up a couple of loose ends ahead of fall break. But nothing we talk about on Monday will be on the exam, because technically you can take the exam starting Monday morning. So questions, comments, concerns, bribes. Okie dokie. So have a good weekend. I will be around this weekend if you have questions as you're studying and want me to review anything. Otherwise, I will see everybody on Monday. You too, Griffin. Have a good weekend.